Good afternoon, my viewers. You're very much welcome to this edition of our class. Today, we shall be talking about fundamentals of motion. Motion, as we know, involves movement from one point to another. Motion is the change of the position of a body. Kinematics is the study of motion in relation to force. Dynamics is the study of force and how they affect the motion of a body. We've talked about motion, which is generally involved. We spelled out kinematics, and in kinematics, force is involved. Dynamics involves the motion of a body in accordance with the force being applied. In terms of the fundamentals of motion, we spelled out what motion, meaning the change of the position of a body. We differentiated kinematics from dynamics. Kinematics is a study of motion in relation to force. Dynamics is the study of motion, the study of force, and how they affect the motion of a body. And that takes us down to types of motion. Under the types of motion, we have the random motion, we have the translational linear motion, we have the rotational motion, and we have the periodic or oscillatory motion. We spelled out 4 types of motion: the random motion, the translational linear motion, the rotational motion, the periodic or oscillatory motion. That takes us to the explanation of the various forms of motion we just enumerated. For random motion, it is an irregular or random or disorderly direction of particles moving haphazardly, meaning it has no direction. A trader who wants to get to a marketplace and has no particular place to move, she has no direction at that point in time because she's going in search, looking for a particular place to lay her wares. When she finds a place where she can sell her goods, she will no longer be operating under a random motion. This time, it's a different form of motion. But on the contrary, it involves collision with one another. We are still talking in regards to the random motion that has no particular direction, is moving haphazardly from one point to the other. It involves collision with one another. You get that? So when we look in terms of the random motion is a haphazard form of motion, moving continuously in different form with no particular direction. Example, particles suspended in water. It has no direction, it keeps hitting one another. Then we have the motion of gas particles. These particles, according to Brownell's theory, moves in a haphazard form, hitting the walls of the containing vessel. The translational linear motion is a motion that involves rigid body, very strong bodies. It moves from one point in space to another. We must understand that in this motion, there is no rotation. Example, a ball is thrown vertically upward, up, down, up, down, up, down. That is an exhibition of its translational linear motion. It's moving in a straight line. A goalkeeper, for an example, who a player shoots a ball to, he shoots the ball back to the player in a translational linear motion. That takes us down to the rotational motion. This involves the motion of a body in circles, in circular form. We must understand here that in this form of motion, it is positioned in the center or axis. Example, the rotation of the earth. You will agree with me that the rotation of the earth is in a circular form. If you look at your electric fan, for an example, it's also done in a circular motion. The rotation of the wheels of a moving car. The 4 tires that make up a moving car is moving in a circular motion, and this vividly explains that the rotational motion involves the rotation of a motion in a circular form. That takes us quickly to the periodic oscillatory motion. In this form of motion, it's in a uniform speed. It's frequently done in a circular form, but it's involves a uniform speed. I mean, everything is done in a frequent way. The motion is done in a circular way, but in a frequent way. For example, an electric bulb. The application involved in the periodic or oscillatory motion is it involves a physical phenomenon involved in light, involved in mechanics, involved in electricity. And all these are various forms involved in the study of physics. The movement of the body in a regular successive period of time explains the periodic oscillatory motion. And its application is found in a wristwatch. When you look at your wristwatch, the movement it makes within a successive period of time explains the periodic motion. Your stopwatch, for an example, is an explanation of a periodic motion because the time is moving at a successive period of time. That is the explanation attached to the periodic or oscillatory motion. Better still, as regards to the periodic or oscillatory motion, we could look at it in terms of an athlete who is given a stipulated period of time to run a race, probably a 100-meter race. Within that period of time, he takes up to the place he gets to his final position. It's being run under a successive period of time. That successive period of time is known as the periodic or oscillatory motion. I'll throw a little light on the pendulum bulb for an example. Now, a pendulum bulb, when you look at a pendulum bulb, even in our experimental class, you see that an experimental bulb moves from one point to the other. When you tap it, for an example, it moves from this point to this point to this point, and then that period of time when it moves explains what is known as the periodic or oscillatory motion. In summary, we're able to talk about types of motion. We explained firstly motion. We talked about the types of motion, where we looked at it in terms of the random motion. We looked at the translational linear motion. We looked at the rotational motion, and we looked at the periodic or oscillatory motion. I'll be right back.